Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Washington, astronomers have detected gaseous water in the planet-forming disk around the star V883 Orionis, about 1,300 light-years away from Earth. The detection of water supports the idea that water on Earth is even older than our Sun, the researchers said. This water, detected using the Atacama Large Millimeter/submillimeter array, ALMA, carried a chemical signature that explained the journey of water from star-forming gas clouds to planets, they said in a study. We can now trace the origins of water in our solar system to before the formation of the Sun, said John J. Tobin, an astronomer at the National Radio Astronomy Observatory, U.S., and lead author of the study. This discovery was made by studying the composition of water in the planet-forming disk around the star V883 Orionis. The study is published in Nature. When a cloud of gas and dust collapses, it forms a star at its center. Around the star, material from the cloud also forms a disk. Over the course of a few million years, the matter in the disk clumps together to form comets, asteroids, and eventually planets. Tobin and his team used ALMA to measure chemical signatures of the water and its path from the star-forming cloud to planets. Water usually consists of one oxygen atom and two hydrogen atoms. Tobin's team studied a slightly heavier version of water where one of the hydrogen atoms is replaced with deuterium, a heavy isotope of hydrogen. Because simple and heavy water form under different conditions, their ratio can be used to trace when and where the water was formed. For instance, this ratio in some solar system comets has been shown to be similar to that in water on Earth, suggesting that comets might have delivered water to Earth, the study said. The team used ALMA, an array of radio telescopes in northern Chile, to observe the gaseous water in V883 Orionis. Thanks to its sensitivity and ability to discern small details, they were able to both detect the water and determine its composition, as well as map its distribution within the disk, the study said. From the observations, the scientists found that this disk contained at least 1,200 times the amount of water in all Earth's oceans. The journey of water from clouds to young stars, and then later from comets to planets has previously been observed, but until now the link between the young stars and comets was missing. V883 Orionis is the missing link in this case, said Tobin. The composition of the water in the disk is very similar to that of comets in our own solar system. This is confirmation of the idea that the water in planetary systems formed billions of years ago, before the Sun, in interstellar space, and has been inherited by both comets and Earth, relatively unchanged. But observing the water turned out to be tricky. Most of the water in planet-forming disks is frozen out as ice, so it's usually hidden from our view, said co-author Margot Leemker from Leiden Observatory in the Netherlands. Gaseous water can be detected thanks to the radiation emitted by molecules as they spin and vibrate, but this is more complicated when the water is frozen, where the motion of molecules is more constrained. Gaseous water can be found towards the center of the disks, close to the star, where it is warmer. However, these close-in regions are hidden by the dust disk itself, and are also too small to be imaged with telescopes, the study said. Fortunately, the V883 Orionis disk was shown in a recent study to be unusually hot. A dramatic outburst of energy from the star heats the disk, up to a temperature where water is no longer in the form of ice, but gas, enabling us to detect it, said Tobin. Thanks for watching. Please subscribe my channel for more videos.